Hi guys. We will try to solve this question. It's a recent question. It came in TIFR 2025. So yeah, last time I also solved this, but I actually made a mistake. So my friend, who is definitely a genius, actually pointed this out. So I mean, the first part was correct, but the answer was correct nonetheless, but like the way, especially the basis that I took was wrong. So I will try to hopefully we'll be able to solve this correctly. So yeah, so in the question, okay, let me go through it like the whole thing again. So in the question it says, let S3 with a symmetric group on three letters. Consider the real vector space V. And what is V? Is a set of all functions from S3 to R such that f of g is equals to f of g cube for all g belongs to S3. Now they are talking about what is the dimension of this space. Now the first thing that when you see like a functions like vector space of functions from a particular set to like another okay here R is actually a real vector space, so it will yeah. So let us go through this basic fact that say uh, R is a commutative ring with unity, commutative ring with unity. Okay, then okay, sorry. Uh, also say S is a set, S is a set. Then this R power S, which is nothing but all functions from S to R, okay, such that support of F is finite. This actually, where support of F is nothing but like basically like it's non-zero at finite number of elements. The rest of them is zero. Okay, so support F is finite. So this actually so so RS is actually forms an R module, right? Now in our given question, okay, let me just in our given question, R is given as real vector space. Okay, so basically, so R is given as real vector space. So this will actually be a field. I mean, so R since R is a field, so yeah, since R is a field, this will be a vector space. So R to the power S3 uh, will be a R vector space. Okay, since R is a field. Uh, So if it was a general commutative ring with unity, then it would have become an R module since R is a field. So it will be a vector space. Now okay. So basically once again, what is R power S3? It's nothing but all functions from S3 to R with finite support. Now since S3 is of course it's finite, so we don't need to care about that part. Now okay, now what about the dimension of this? Okay, so the dimension now this will be spanned by like all the characteristic functions, right? Right. So let me just write S3 here. So it's identity element transpositions, three transpositions, 1 2 1 3 and 2 3 and 1 2 3 and 1 3 2. Three cycles. Okay. So yeah. So since S3 is this, so basically uh, uh okay. So basically, RS3 will actually be spanned by chi of E, chi of 1 2, chi of 1 3, chi of 2 3, uh, chi of 1 2 3, and chi of 1 3 2. Right? Where this uh, where this is nothing but the indicator function of the characteristic function, that is like chi of sigma is nothing but chi of sigma g is nothing but uh, chi of sigma g is nothing but let's say 1 uh, if g equals sigma and 0 if gn equals sigma. Typical characteristic function. So as you can see, so this will actually so this will actually span the whole f like whole like the vector space, right? Since okay, let me just since like so basically like we can take any functions from S3 to R and we can write it as some linear combination of AI, some linear combination of AI chi of sigma I, where sigma runs from 1 to 6. Okay, so yeah, so so basically the dimension of this will be 6. Okay, so the dimension of this will be 6. This is the whole vector space. All right. Now in our given question, we need to, so basically V will be a vector subspace of this, right? Okay. Since basically in V we want all such functions with finite support, of course, such that f of g is f of gq. Okay, for all g belongs to S3. So we want all such functions. Now, so yeah, so basically if we can find some like characteristic function, let's say, I mean basis elements which satisfy this, right? Which satisfy, right, f of g equals f of g cube, like for all g belongs to S3, then if we can find certain basis element which satisfy this, then we can actually like we can actually extend by linearity, or basically a linear combination of those basis elements will basis I mean basically linear combination of such characteristic function will result in a function which will satisfy all this, right? So basically we want, I mean by doing that we can get an idea of like how big the space is, or basically the dimension of the space, right? So the idea is, so chi of sigma g is chi of sigma g cube, right? This is true for all g belongs to S3. Now, like we take G to be S3. Okay, so now basically taking G equals to sigma. Okay, we are taking G to be sigma, so it will give us chi of sigma sigma chi of sigma sigma k. So basically all character, so which will actually imply that sigma equals sigma cube, right? So basically all such characteristic functions which satisfy this, okay, so will actually, like, be in that vector space V, right? So basically, like, transpositions, okay, all the transposition uh, and like 2 3, right? 1 2 1 3 and 2 3, so basically they will satisfy. So right, chi of 1 2, chi of 1 3, chi of 2 3. So now one might be tempted to think, so this will actually, like, this will actually, all of them will belong to V. Now one might be tempted to think that, okay, like identity also satisfies this, but why is identity not? And that's where I made the mistake last time. So now so now, if like, yeah, that is true that chi of, yeah, E is nothing but chi of EQ, but chi E of 1 to 3, a 3 cycle. Okay, so this is 0, right? And chi of 1 to 3 whole cube, I mean 3 for power 3, I mean, order 3, that will be identity, which is 1. So both are not equal, right? So identity won't be there. Okay, right, identity won't be there. So basically this 3 will belong to the subspace V. Okay, so like we can, so basically dimension of V will be 3 or greater than 3. Okay, so in our question it's given 1 and 2. So 1 is false, 2 is also false. Now it might be 3 or might be greater than 3. Okay, now, but the thing is, like, suppose this is actually where my friend actually helped me out. So he said, like, suppose if we take a constant function, let's say fg is g, right? For all, sorry, fg is, so it will be a real value. So fg is 2, let's say for all g belongs to. So this is a constant function, right? So basically, we can't write constant function as a linear combination of this chi 1 2, chi 1 3, chi 2 3. Like we can actually try to, like let's say we write chi 1 2 plus chi 1 3 and plus chi 2 3. So if we write it like this, like for the if we put f of 1 2, okay, like this will be 1 and the rest will be 0. For transposition it is fine. Now for if it is identity, like say f of e, then everything will be 0, go to 0. So but we don't want that, we want it to be 2 because it's true when f of g is true for all g belongs to S3. So we can't write it like this. Okay. So basically we actually and also this actually f belongs to v, since f of g is f of g cube, since it's a constant function, right? So basically we actually found a function which is not, which is not spanned by this. So basically dimension of v is greater than 3. Okay. So our answer is done now. So this is true and this is false. Now we can actually take this a step further, right? Like, okay, so dimension of V is greater than 3. So what is the dimension? It might be 4, it might be 5. So let's just go above and beyond and try to find like such like basis which actually gives us this. So okay, so let me define, right? So let me define chi identity. So I mean, how can we like include that identity? Like the okay, so let just include this. So let's say chi identity 1, 2, 3 and 1, 3, 2. Okay, so this is nothing but this is nothing but uh this of G is nothing but 1. Okay, if G equals to identity 1, 2, 3 or 1, 3, 2. And 0 if g unequal if otherwise, right? 0 otherwise. All right. So and okay. So and if we look carefully, like so v will be spanned by this chi of 1 2, chi of 1 3, chi of 2 3, and chi of this big thing 1 2 3 1 3 2. So dimension of V will be 4. And once again, since they will be linearly independent, right? So dimension of V will be 4. And now what is this thing? If we look carefully, so chi of this is nothing but chi of identity, chi of 1 2 3 plus chi of 1 3 2. So this is nothing but the sum of this, right? And this actually belongs to V, right? So if we take G to be a transposition, everything here will be 0. Okay, okay, everything here will be 0, and this will satisfy chi of that transposition and transposition cube, which is nothing but a transposition once again. Okay, so now what about E? If we put E in place of G, the rest chi 1 to 3, this term and this term will go to 0. This will be 1. So, and what about 1, 2, 3? If we put a 3 cycle, chi of 1, 2, 3, so that will be 1, since this will go to 0, and 1, 2, 3 whole cube, which is nothing but identity, since 1, 2, 3 has order 3. So this will be identity. So this and this will go to 0, this and this, so this will remain. So basically this belongs to V, and this is is a sum of all these like the basis elements, characteristic functions. So and this is linearly independent to this. Okay, so our dimension of V is 4. Dimension of V. So this is a mistake I actually made last time. I actually included chi of V. So that is a problem. And one more thing, let me do it in the next page, is that like now we can actually write the constant function. Let's say f of g is 2, right? So this actually belongs to V. This f of g belongs to V. Okay. So now, uh, right, we can write f of g to be twice of chi 1 2, chi 1 3, chi 2 3 to that big thing. Okay, so let me just write it properly. Uh, one, uh, sorry, yeah, identity 1 2 3 1 3 2. Okay. So notice, like, if we put anything transpose, so this actually satisfy this whole thing belongs to V. And if we put anything, let's say identity, everything will be 0 except that. So f of identity is 2. So this is actually very beautiful. F of identity is 2. F of, you know, f of identity 2, f of 1, 2 is 2. Okay, so f of 1, 2, 3, which actually will be 2, and so on. So basically, so we can actually span a constant function. So yeah, so this actually will be the whole space. Right. So yeah, so dimension will be 4. So now if we so basically if we write in terms of, since it's a dimension of the whole, right? So since dimension R is 3 is 6, so basically we can say this is actually isomorphic to, since it's finite dimensional, R6. So basically the basis, like if we translate it to, if we like the order, like I mean I was talking about basis, I mean like ordered basis basically will be, right? So so it will be, yeah, 0 1 0 0 1 2 3 4 5 6. Okay, 1 3 0 0 1, yeah. Since like I have actually written identity 1 2 1 3 2 3 1 2 3 1 3 2. So since I've written it like this, so this will be second, and that will be 1 0 0, and the final one will actually be, sorry, the final one actually be 1 4, yeah. So the final one will be like this. So basically that we will be spanned by something like this, right? I think, yeah. So we will actually be spanned by something like this. So since it has dimension 6 and all these are all the characteristic functions, so yeah. So this is our question. So answer will be 4 and it will be greater than 3. Like we have already solved the question like here, so we actually didn't need to do all that, but still this up to this, this is clear that like the constant part, okay, so dimension v is greater than 3 and so basically we are done. Okay, but if we go a bit more we can actually see that dimension of v is 4 and this is our solution.